All right, today we're going to look at stingless bee honey, but through a really cool lens, its architecture. We're going to see how the actual structure of a bee's home, whether it's a wild nest out in nature or a man-made hive on a farm, completely changes the honey that's inside. So let's dive right in.
First up, I want you to think about something. When I say honey, what pops into your head? Probably a thick, golden, super sweet liquid, right? But what if that's only one side of the story? What if honey could be something totally different?
Well, it turns out that in the tropical parts of the world, there's a special group of bees, the Meliponi, or stingless bees, and they produce a honey that just shatters all our expectations. It's this prized, complex liquid that people have been harvesting for centuries, and trust me, it's a world away from what you'd find on a typical grocery store shelf.
So, let's get into it. What exactly makes this honey, often just called SBH, so incredibly different from the stuff we're all used to?
Okay, here's the breakdown. Stingless bee honey is naturally really high in moisture and acidity, and its sugar makeup is completely unique. And all of that together means you get a honey that's way more fluid, almost watery, and it often has this tangy, sour, almost fermented taste. It's a super complex flavor that kind of hints at just how powerful this stuff is. Now this is where it gets really wild. Look at that moisture content. This honey can be anywhere from 23 to almost 38% water. To put that in perspective, the regular honey you get from honeybees has to be under 20% moisture by law. Otherwise, it starts to ferment. But with this honey, that high moisture is the whole point.
And that is the absolute key. This isn't a bug, it's a feature. That high water content, mixed with its natural acidity, basically kicks off a fermentation process right there in the hive. And that process creates all of these amazing bioactive compounds, which is exactly why this honey is so famous for its health benefits. Everything from antioxidants to antimicrobial properties.
So to really understand this honey, you've got to start at the source, in the wild. We're going to look at the original architecture, what you could call nature's blueprint for how these bees build their homes and store their liquid gold.
You see, unlike the big, hanging hives we all picture, stingless bees are super creative architects. They build their nests in these hidden, protected spaces, tucked away inside hollow trees, deep down in underground burrows, inside cracks in rocks, and hey, sometimes even in man-made stuff in cities.
And the inside is just brilliant. In a wild nest, the bees build these special little pots just for the honey, and they keep them totally separate from the area where they raise their babies, the brood. These pots are made from a mix of natural wax and antimicrobial plant resins. The whole thing is organic, irregular. It's a complex fortress built for survival.
Okay, so that's nature's design. That's the blueprint. But as this honey has gotten more popular, we started farming it. So the big question is, how does the neat, simplified world of a man-made hive change that natural architecture?
Well, right away, there's a huge change in organization. Out in the wild, there's a protective wall that separates the honey from the brood. In farm hives, that separation is often gone, or at least much smaller. And why? It's simple. It makes it way faster and easier for us humans to get the honey out.
Next up, building materials. Wild nests are 100% natural, built with wax and propolis, that special resin that has antimicrobial properties. Farm hives, though, often use artificial materials like wood or plastic. And that can totally change the environment inside the hive, affecting everything from moisture to the microbes living in there.
And that brings us to the overall layout. Nature's design is this complex, layered fortress, perfectly adapted for what the colony needs. The farm design? It's simplified, boxed off, and standardized. It's a shift from a living, breathing home to an efficient factory. The architecture is being optimized for humans, not for the bees.
So you might be wondering, why does all this architecture stuff matter? Well, because all those differences leave a very distinct chemical fingerprint on the honey itself. The structure of the hive has a direct impact on the final product.
And at the very heart of that chemical fingerprint is a kind of secret ingredient. It's a rare sugar that makes stingless bee honey truly one of a kind. Trehalulose.
Just look at that range. Trehalulose can make up anywhere from 13 to a mind-blowing 57% of the total sugars in this honey. This isn't just some tiny trace element. For a lot of these bee species, it's one of the main sugars, something you just don't see in other honeys.
So what's the big deal with this one sugar? Well, for one, it's what keeps the honey so runny and stops it from turning into crystals like other honeys do. And second,
Because it's so rare, it's the perfect biomarker. If someone's selling honey that they claim is from stingless bees, but it has low levels of trehalulose, something's not right. It is the ultimate authenticity test.
So you have this incredibly complex, unique product, but it's facing some very modern challenges. Let's zoom out a bit and look at the future of this liquid gold and what we need to do to protect it. And here is the fundamental problem. We have this amazing, powerful natural product, but there are no real global standards for it. The rules we use for regular honey just don't work here. Its high moisture would make it fail most quality tests, even though that's the very thing that makes it so special.
So what's the path forward? It really comes down to three big priorities. First, we need new international standards that actually recognize what makes this honey unique. Second, we have to expand the research. I mean, there are hundreds of species of these bees, and we've only really studied a few. And third, we can bring in modern tech like sensors in the hives to monitor quality and help make farming more sustainable.
Which brings us to our final question. The whole story of stingless bee honey is really a story of two architectures. You have the ancient, complex blueprint of nature on one side, and the simplified, efficient design of modern farming on the other. The real challenge is finding the right balance. Can we use modern science not to control nature, but to better understand and protect this incredible liquid gold for the future?